guys, we are coming to the end of chapter 5, and we're located at 5.5, and we're going to talk about this really cool theorem called the triangle inequality. And I'll tell you why I like it, because I remember learning about it and thinking, whoa, that doesn't make sense. So, I mean, it makes sense, but it was like, whoa, I can't believe I never thought of that. I think that's more the passion that I had. So basically, what I tell students to do when we're thinking about this, and I say, given any three sticks, can you make a triangle? If I gave you these three sticks, can you make a triangle? And usually the thought is, yeah, if you have 3 sticks of any length, you can make a triangle. And then you actually get into it and you start realizing that, wait a minute, I probably can't. So let's take this stick, for instance. Let's turn it around a little bit. Let's turn it around. And let's see, can we make a triangle? Do 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 do. And you're carrying things around, and you do do do, and then you start twisting, and you move, and you're saying, okay, yeah, this is about it. And then you're trying, and then you start to look, and you're like, wait a minute, I cannot actually make a triangle if I just had any 3 random sticks. Any 3, that just made that a little larger, but you know what I'm saying. Like, this will never make a triangle. So given 3 lengths, you cannot necessarily make a triangle, and the triangle inequality theorem gives us an opportunity to kind of guarantee that the 3 sticks or the 3 legs or the 3 sides that we have would create a triangle. Kind of neat. Okay, so what does it mean? The sum of 2 lengths of any 2 sides of a triangle must be greater than the third side. So let's go back to my little analogy here, my little example. The sum of any 2 sides must be greater than the third side. And you can see exactly the failure that has happened. This side here and this side here is not greater than this third side. Like this side, the length of this side plus this side, totally greater than this. The length of this little side plus this big side, totally greater than this. But the length of these 2 little sides that I'll highlight in red, it's not greater than this larger side, and therefore it can't make a triangle. If you think about these 2 sides being on hinges, they would just whoop, whoop, fall flat and never actually make a triangle. So it must be greater than, and not equal to either, because if this side plus this side was equal to the sum of these 2 sides was equal to the sum of this side, then they would not ever make a triangle, because they would end up just laying down exact flat on it you know what I mean? Is that making sense? Are you sure? Anybody listening? Okay. So anyway, the triangle inequality theorem is written this way. The sum of the lengths of any 2 sides of a triangle must be greater than the third side. So red plus blue must be greater than green, and blue plus green must be greater than red, and green plus red must be greater than blue. So here in example 1, we're going to identify possible triangles given side lengths. So if I've got 8 inches, 15 inches, and 17 inches, will this make a triangle? And so basically what we need to do is make sure that the sum of any 2 sides is greater than the third side, right? Well, clearly what I like to do is basically make sure that the 2 smaller ones would be greater than the larger one, the 2 smaller sides. So 8 plus 15 is clearly greater than 17. 8 plus 15 is going to give me 23 inches, and 23 inches is greater than 17 inches. And then we can assume that, all the rest works out. 17 plus 15 is greater than 8, and 8 plus 17 is greater than 15. And therefore, because we have that, we know that it is possible to form a triangle with these lengths. All right, so let's take a look at part B. We'll do the same thing. And again, really, I know that these 2 added up has to be greater than this one, right? Because 14 is bigger. So, I mean, yeah, like these 2 added up has to be greater than this. And then the big one plus the little one has to be greater than the middle one, just because the big one's bigger. But the real question is about the 2 smaller ones. Is the sum of the 2 smaller ones greater than this other side? And so 6 plus 8 is 14 meters. 6 meters plus 8 meters is 14 meters. And I have a situation where they're equivalent, which is not what I need. So no, these lengths will not form a triangle at all. Yeah, these lengths won't form a triangle because the sum of 2 sides isn't greater than the third. The sum of these 2 sides, it's not greater than 14. It's equal to 14, but not greater than. No triangle here. So this is a fun one. If the measure of two sides of a triangle are 3 feet and 7 feet, which is the least possible whole number for the third side? So we've got 3 and 7, and we need another side that's going to be the least possible whole number. So you remember that whatever this number is, when I add it to 3, it has to be greater than 7. When I add it to really, this is the important part. When I add it to the small number, it has to be bigger than 7. So it can't be 4 because 7 minus 3 is 4, right? And that would just be equivalent. It has to be greater than 4. And the only number that works here for the, the least whole positive number that would work for that would be 5. 10 doesn't work at all because, can you see why? 3 plus 7 is 10, and then you get the sum of two sides equaling the third side and not greater than the third side. So 5 really is the only number that works at all of these answer choices. Though we could choose like other numbers, like 6 would work, and other numbers like that. All right, so hopefully that kind of made sense. If you have a situation where you have a standardized test and you're taking something like this and it's multiple choice, it makes perfect sense just to substitute in each option and see which one fits. Okay, so finally we come to example 3, which is another not so real world example, but it's not terrible actually. So there's a lot of information here, and I hate to be like one who's not going to read, because I just found myself reading this over and over again and feeling like, what am I talking about? So here's the gist of it. The gist of it is this flight and this flight, we need to prove that these two flights, the length of these two flights is greater than this one. And the information that we're given is that this flight and this flight are equivalent. And I think right there you can already see what's going to happen. So the scaled down model of it is basically that this is A. CA and CT are equivalent. We need to prove that CL plus LT is greater than CA. And that's not going to be a hard proof. I'm going to write down the gist of the proof. As you know, you don't have to write down the first statement as the given, but I did, and that's fine. So basically what I'm going to do is utilize CL plus LT must be greater than CT, and we remember that from the triangle inequality theorem. So CL plus LT I know is greater than CL plus LT is greater than CT, and that's from the triangle inequality theorem. Triangle inequality theorem. Okay, and then the next thing I'm going to do is basically say that CL plus LT has to be greater than CA. And what I've done is I've just done a little bit of substitution there, right? And so that is by substitution. Substitution, I can spell it, I promise. And I'm going to just put substitution 1 comma 2. And sometimes I like to do that just to say, what are the statements that I'm substituting? I'm substituting 1 comma 2, and pretty much I'm done. That's it. Okay, with that in mind, my good friends, do I have another one? No, I don't have another example. With that in mind, we're done section 5.5. And we are moving quite rapidly through the chapter. Let me know if there's any questions, concerns, problems, setbacks, or things you just want to hang out and discuss. Look forward to talking to you soon. Take good care. Bye.